Um, let's talk about trigonometric identities. Um, First of all, I want to talk about the Pythagorean identities right there. Um, some people like to actually remember this in a short note ways. You really need to remember that the main Pythagorean identity is sine squared x plus cosine squared x equal to 1. And then you can find all the other ones. And in the other videos, we do that using just that and knowing your cotan identity and tan and secant and cosecant identities. But let's start with another trick, because we may or may not want to every time drive every formula. And so I'm writing sine, cosine, tangent, cotangent. Co-functions are all in a corner. So for example, I wrote that was wrong. Secant of x, cosecant of x. Put a 1 in the middle. Draw from all sides. And then so the 6 corners, and then every corner that everywhere you can put a triangle, upside down triangle like that, put 1 in there. Put a plus on top and equal sign, plus and equal, plus and equal. So this way I'm saying sine, if I go sine squared plus cosine squared, I get 1. So that's 1. And in here it's saying 1 plus tangent squared. This is tangent, put a square on all of them. And tangent squared plus 1 gives me secant squared. 1 plus cotangent squared gives me cosecant squared of x. Over here, because sine squared plus cosine squared is equal to 1, if I subtract sine squared from both sides, I get what is left is cosine squared. If I subtract cosine squared from both sides, I get sine squared of x. What is remaining is the secant squared minus tangent squared. If I subtract tangent squared, I get 1 in here. And so some of these formulas may come in handy. By the way, there's something else notice in that mnemonic that we provided over here, that tan and cotan are inverse of each other, and sine and cosecant are inverse of each other, and cosine and secant are inverse of each other. So it does multiple identities, that basic identities can be memorized through this mnemonic. Now, let's try to verify this identity. And how do I do that? Let's start from one side and see if I need to simplify the other side or not, because the other side is very simplified. I think I can get away with simplifying one side. By the way, if you're simplifying, don't write one side equal to the other side. That's what you're trying to prove. Even if you're simplifying both sides, you have to simplify them separately. So I'm separating the left side and simplifying it. That's what is secant theta minus tan theta plus cosine theta over secant theta plus tan theta. And then I distribute sine theta, cosine theta over secant theta minus tan theta plus sine theta cosine theta over secant theta plus tan theta. Okay, so I distributed through. What I notice is that I have different denominators, same numerator. So maybe if I find a common denominator, it will help me. So that's what I'm going to do next. So the common denominator is the first one times the second one. By the way, I could have done the common denominator first, then distributed. It doesn't matter. Might be slightly different in how messy things gets, but not a whole lot. So when I'm doing common denominator, basically, I'm multiplying both of these by the other denominator, secant theta plus tan theta, secant theta plus tan theta, and multiplying both of these by the other denominator. Put parentheses so it will not be wrong. And so therefore I will have a secant theta plus tan theta here. And sine theta cosine theta times secant theta minus tan theta. Now let's try to simplify the denominator. I can see that this follows an a minus b times a plus b formula when a is secant theta and b is tan theta. That is, I'm going to get a squared minus b squared. I could also FOIL and get the same answer. So the denominator is secant theta minus tan, secant squared theta minus tan squared theta. And the numerator, I can multiply things through, and I get sine theta cosine theta secant theta plus sine theta cosine theta tan theta plus sine theta cosine theta secant theta minus sine theta cosine theta tan theta. And notice that these two cancel each other out. Going back to this identity, the denominator ends up to be 1, and therefore I'm going to get 2 sine theta cosine theta secant theta. If you remember, to the identities up there, we said cosine theta and secant theta are reciprocal of each other. Therefore, the two of them simplify each other out, and you end up with 2 sine theta. Or you can use the reciprocal formula for this is 1 over cosine theta. And then you end up with the, so you started from left hand side, you ended up with right hand side. Hand side. And you did that, you separated both sides. You didn't simplify both sides to end up with something. Started from left in this case, ended up with the right. I could have started with left and simplified, and then started with right and simplified and got the same answer. That would have been okay also.